Today we are investigating dilations. On this graph, the blue triangle is called the pre-image. The red triangle is called the image. The center of dilation is currently at the origin 0, 0. Change the scale factor by dragging the black point labeled scale factor. How does the image compare to the pre-image when the scale factor equals 1? So when we're saying how does the image, that's the red triangle, compare to the pre-image, the blue triangle, when the scale factor equals 1? Let's set the scale factor equal to 1. What happens? The pre-image and the image are the same triangles. They are congruent to each other. If you adjust the scale factor less than 1, notice how it's a similar triangle to the pre-image, the blue image, compared to the red one, which is the new one. It has the same shape, but it's different size, but it also has the same orientation. So that's when it's less than 1. It's getting smaller than the pre-image. Now, if it goes greater than 1, notice how it gets larger than the pre-image. It's the same shape, same orientation, but a different size. Again, the blue triangle is called the pre-image, and the red triangle is called the image. How does the image compare to the pre-image when the scale factor is less than 1? So again, here we have our triangles. The red is stacked on top of the blue because their scale factor is equal to 1. Again, the triangles are congruent. If we make the scale factor less than 1, notice your blue triangle, the pre-image, the original triangle, and the new triangle, the red triangle, that's your image. If it's less than 1, your scale factor, right, it gets smaller. Same shape, same orientation, different size. So again, it's shrinking, it's getting smaller. Still having the blue triangle be the pre-image, the original, red triangle is the new image. How does the image compare when the scale factor is greater than 1? Well, notice the triangle has the same orientation, same shape, but different sizes. And as I continue to grow the scale factor, it gets larger and larger and larger. Now move the center of dilation point to each of the vertices of the pre-image. Remember, the pre-image is the blue image on the triangle. How do the angles of the image compare in size to the angle of the pre-image? So again, we're going to move the center of dilation to each vertex of the pre-image triangle. So notice what happens here. See how they're lining up? Your image, the new red triangle on your blue pre-image, the original. We have the congruent pair of angles here at the point 3, 4. Again, if I move the center of dilation, we have another pair of congruent angles here at 7, 4. And if I move it to the third vertex of the triangle, you have another congruent pair of angles here at 6, 1. So the triangles have 3 pairs of congruent angles. Again, notice how all those sides were lined up when we moved the center of dilation. And there appears to be a pattern between the relationship of the pre-image, the blue, compared to the red. Now, what was your scale factor set at? It was set at 2. Well, if you're thinking about the blue to the red, if the scale factor is at 2, that means it's twice as big, right? I could fit 2 of these blue triangle lengths here. Same thing, 2 here. And if I moved it, this vertex here, 2 here. So again, if we're moving the center of dilation to each point of the pre-image, we're looking for the sides of the triangles, okay? And we've done this with a scale factor of 2, but what if we did it with a scale factor of something less than 1? What if we did it at 1/2? Well, let's see what happens. We have a pair of congruent angles at this vertex, a pair of congruent angles at this vertex, and at this vertex. And notice how the sides were all still lining up as before. So we've got the same shape, same orientation, but how does the original image in blue compare to the one in red? Well, the red one appears to be half the size, right? If we look at this, we can count, that's 4 units. This is 2 units this way. And then if we use our slope to see how we were going down and over, notice how that's half the amount, so that's half the length here. And if we adjusted that here and we used our slope again, looking at from point to point, notice again how that's half the amount. So that's half the amount there. I move my center of dilation here, and I use my slopes to tell me from the original to my new, half of the amount there. So when the scale factor was less, right, it got smaller, but it's still in that proportion to the original triangle. So here we want to adjust the vertices of the pre-image. Remember, that's blue, and the image in red with the center of dilation and the scale factor. And what do we notice? Here we have another set of triangles. So again, we're starting off with that scale factor of 2. So if we went to the scale factor of 1, notice how the pre-image and image are the same. They're congruent. We had the scale factor at 2. And again, if we adjust the vertices of the pre-image with the center of dilation, notice we're getting 3 pairs of congruent angles. The sides are still aligning. If I compare the blue with the red, think about the slope. We're going down 1 to the right 2. Compared to the red, we're going down 2 and to the right 4. That's half the amount. And again, if we adjust this and we look at the slope in blue, down 1, right 2. And again, if we look at the red, down 2, right 4, half the amount. And if we check, that's happening for each of the vertices of the pre-image to the image. If we went to the scale factor of 1/2, comparing the pre-image to the image, blue to red. And again, we're checking the angles, staying consistent, 3 pairs of congruent angles. If we looked at the slopes of the sides, here's our vertical, so it's undefined, but it was 2 units to get to that point. Now it's only 1. Looking at the slope here in blue, that was down 3 and to the right 2. Notice how this is down 1.5 and to the right 1. That's half there. Looking at our slope here, going down 1, right 2 versus our slope here. We've got our match as well. So it's still staying consistent. So we know that the dilations, adjusting the scale factor, causes the shapes to be similar. They have the same angle measurements and the sides are in a proportion to each other, right? So similar triangles, and we could do this for our other polygons as well. All the corresponding angles are congruent and all the corresponding sides are proportional. The constant of proportionality is what we call our scale factor, and that is used to describe the amount the image has changed from the pre-image. Again, that changes your dilation, your scale factor. So the scale factor ratio is using the corresponding sides, taking the image and comparing it to the pre-image. So remember we said our image was what was in red, our pre-image is what is in blue. So if we take kind of the new triangle comparing to the original, that helps us with our scale factor. If we know the scale factor and then a side length of the triangle, we can use that to predict the other sides of that triangle because they would be in the same proportion. For example, here we have our pre-image, the original triangle. Here's the image, the new triangle. And again, notice the original ABC that's listed here. Compare it to the new A prime, B prime, C prime. Okay, that's here. Looking at the scale factor. Let's take a look at the angles. We have angle A with A prime. Notice how they're the same with 37. Angle B with B prime, 53s. C with C prime, 90. So we have the corresponding angles that are congruent for our similar figures. Now we're going to compare the sides. And we said take the image, the new one, compared to the pre-image. So our A prime, C prime, which is 8, compared to AC, which is 4. 8 over 4 has a common factor of 4 to divide out, which would be 2. Again, let's check our B prime, C prime with BC. 6 over 3, divide out your common factor of 3, that's 2. Check your next one, B prime, A prime with BA. 10 over 5, divide out your common factor of 5, that's 2. So our scale factor here is 2. Here we have a new set of triangles. Again, we're trying to determine the scale factor. And if you look at the tick marks of the triangles, they're saying that you have 3 angle pairs that all happen to be the same measurement. Remember, we call these equilateral triangles. So we know the angle measurement for each of these angles would have to be 60 degrees. So what's the scale factor? We're comparing the image to the pre-image. So let's look at the givens. If they're equilateral, all the sides are congruent. So every side in your triangle A prime, B prime, C prime is worth 5, and your triangle ABC is worth 4. So if we were going side to side for the corresponding ratios, we'd have 3 sets of 5 to 4. 5 and 4 don't have any common factors of the 1 to divide out, so that would be our scale factor, 5/4. Now you may write it as 1.25, but you'll see that the fraction will be more helpful for you as you're doing calculations going in the future, especially without a calculator, than the decimal equivalent. All right, here we have a new set of triangles. Again, we're trying to look at the scale factor. So we're going to compare our triangle image, A prime, B prime, C prime, to your pre-image, A, B, C. If we look at the corresponding parts, we have only one pair of corresponding sides that we could use to write our scale factor. And those happen to be the hypotenuses of the triangles. That is your 5.65 compared to 8.33. So 5.65 compared to 8.33, there's our scale factor. This one is not as nice looking as our previous ones. It's a non-repeating, non-terminating decimal, right? It's an irrational number. So here's our scale factor, and we could just leave it like this for right now to use for calculations going forward. Again, the fraction will be more helpful because that's the exact scale factor versus the decimal, where we have to do some more rounding involved. All right, here we've got our triangles, our original pre-image in blue, ABC, compared to the new A prime, B prime, C prime. What's the scale factor? So again, let's take a look. We can see we've got our angle A's being reflexive here, so that's congruent to itself. B prime goes with C, and C prime goes with B. So let's see if we can match some common sides to get the scale factor. Well, this AB prime would go with AC, but unfortunately we don't have a measurement to compare that with. AC prime should go with AB, but again, we don't have that measurement for AB to compare. B prime C prime should go with CB, so we have 3.63 compared to 6.71. That would be our scale factor. Hopefully you're feeling confident with determining the scale factor for your similar figures. Again, look to see to match the corresponding part. Use the angle measurements to help you, or the angle tick marks, always going from the image, your new triangle, to the pre-image, the existing triangle.